to discuss the concept of rectangular coordinates, and this discussion starts with this figure here, this grid. This grid is a brilliant discovery by a man named René Descartes, and for that reason it's called the Cartesian plane. Sometimes it's also called the rectangular plane. Sometimes it's referred to as R2, and that's a double stroke R, meaning all real numbers in both directions, or also R cross R. But all these terms are referring to the same thing, the Cartesian plane. And the Cartesian plane is a great way to bridge algebra and geometry. So not only do we have some sort of algebraic expression, now we can attach some sort of geometric picture to this. And it's really opened up a lot of doors in mathematics. Alright, so you see here I have this grid, and it's going one direction, the left and right direction, and you can imagine this is going from negative infinity to infinity. Typically this is my x direction, we call this the x-axis. And then I'm running in the positive and negative direction, or the up and down direction, and that's called my y-axis. And you can imagine that's going from negative infinity to positive infinity in the up and down, the north-south direction as well. Alright, now you can also see that the plane's broken into 4 regions based off this idea. And so here we have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Okay, and if you have a hard time remembering that, remember the numbers go counterclockwise. And this little point right in the center is what I call my origin. Okay, now the idea is if I want to take a point or an ordered pair AB, I can map this point on the grid. So here I want to map this coordinate AB, and what this is referring to is an x coordinate and a y coordinate. So I have an x direction and a y direction. So let's just say, for example, here my point is AB. What this means is I had to go A distance in the x direction, and I had to go B distance in the y direction. And so once you coordinate those points, you get to the point AB. And it's that simple. Alright, now I'm going to show you some examples of this, and I think it's going to make sense. So for example 1, I want to locate the following points. Alright, so for A, I have the point 2, negative 3. Now, remember what we said. So here I have my grid. That means I need to go 2 in the x direction first. Remember, this is the x, and this is the y. So I go 1, 2, that far in the x direction. Negative 3 in the y direction, which means I start at 0 and I go down 1, 2, 3 there. And then I just see where these two intersect, and there it is. That's the point 2, negative 3. Alright, now we can try the same with negative 1, 5, and if you get confused in which direction you need to start, just remember it's always x first, then y. So I need to go negative 1 in the x direction, and 1, 2, 3, 4, 5 in the y direction. So here the intersection of those two, we have negative 1, 5, there's that point. And then the third one, part C, I have 9, 6, so I need to go out 9 in the x direction. So I can start at 5, 6, 7, 8, 9 here, and 6 in the y, so it's 5, 6 here. And so match it up carefully. There's the point 9, 6. Now if I wanted to talk about quadrants, my first one down in this region is quadrant 4. So part A was in quadrant 4. Part B was up here in quadrant 2, and then part C was up here in quadrant 1. Now another thing you can do with these coordinates in this grid, the Cartesian plane, is you can actually graph equations. So we've seen equations like A, y equals 2x minus 1, and we know how to solve them if y takes on a certain value. One way you can actually think of equations is actually an infinite set of points. So what that means is exactly this. If I set up a table, x and y, and I pick some x values, let's say I pick x be 0, and I plug in 0 for x here, I end up with y being negative 1. If I plug in x equals 1 in for x, I have 2 times 1 minus 1, y becomes 1. And I can keep doing this, and if you notice, each time I'm doing this, I'm generating a set of points. So if negative 1 in for x, I get negative 2 minus 1 gives me negative 3. And I could keep going forever, actually. So if I plug in 2, we'll do one more. I get 2 times 2 is 4, minus 1, I get positive 3. Now, associated with each one of these rows in this column is a point. So the first one I have the point 0, -1. So if I take my grid and I start plugging in these points, so let's see I had 0 in the x direction, -1 in the y, there's my first one. I go 1 in the x, 1 in the y. If I go -1 in the x, I go -3 in the y. If I go 2 in the x direction, I go +3 in the y. And if I keep filling in these points, and mine's not exactly to scale, what you'll notice is in this one, we get a straight line. Something like this. And that's why we call equations like this linear equations, because they generate lines. Alright, now in part B, I could do the same thing. Let's see what kind of shape we get here. So I'm going to pick an x and y table. Let's plug in 0 for x. If I do that, I get 3. If I plug in 1 for x, I see that's 1 squared is 1, plus 3, I get 4. Let's try -1. If I plug in -1 for x, -1 squared is 1, plus 3, I get 4 again. So I have two coordinates now that have the same y coordinate. Alright, let's try one more. Let's do 2. If I plug in 2, that gives me 4, plus 3 is 7. And notice if I plug in -2, that becomes +4. -2 squared is +4, plus 3 I get 7 again. So it looks like I have this kind of mirror image thing going on with my x coordinates. If I have a negative x coordinate, I get the same y coordinate. When I start to graph this, let's see what happens. Okay, when I go 0 in the x, I go 1, 2, 3 in the y. If I go 1 or -1 in the x direction, I get 4 on both sides. If I go 2 or -2, I get 7 on both sides. And if you're unclear about the shape, just keep filling in dots. What you'll see though is that you'll get this kind of round shape, and mine's not too great. There's not supposed to be a dent there. You get this round shape that we call a parabola. And quadratic equations like this generate parabolas in their graph. I'm going to show you how to do some of those same examples through a free website called Desmos.com. And I recommend logging on, setting up an account. It's very useful in these graphing situations. So for example here, you see the grid, and I can zoom in and out and move it around how I need. And typing in things is super easy. So for example, we had some points like 0, -1. And there it is. There's my point. We also had the point 1, 1. And there it is again. And what was another one we had? -1, -3 as a third point. Okay, and you can see those points instantly. Now also I can type in equations and instantly see the points that I need. And so there it is. Notice the black line passes right through all the purple dots that we had. Because remember, those purple dots were solutions to our equation. Okay, now if you don't like these colors, like if you want to change it from black to something a little bit more visual, you can come up here to settings and change the style. There you go. You can even do a table if you want. So here's some points just like we did earlier. It just kind of gives you an idea of what to expect. Alright, what about quadratics? So we can look at the quadratic equation we had earlier, which was x squared plus 3. And there it is. And now I can also see how that works alongside my other one. So Desmos is very useful. I'm actually going to use it in a lot of my videos. Again, set up an account. And if you have any questions on any of this, please let me know. I'd be glad to help. Thanks for watching.